mode, which is Delta V mode, actually is a control mode for the spacecraft. It allows us to slew much more quickly, to continue pointing at this suspected Centaur impact point, even though the shepherding spacecraft will be impacting a couple of kilometers away. This is the last minute before the shepherding spacecraft also impacts the surface of the moon, and the last minute of flight. We're watching the remaining few seconds of the LCROSS mission as we approach very rapidly the surface of the Cabeus crater.
That was it?
Mark, transition to DV mode.
Oh.
Flight,
Confirm
NIR2, OPR change request, NIR2 to OPR 10, over.
Is that November? NIR2 to OPR
Yes, confirm.
10.
November,
Ready. Command flight send November IR2 to OPR 10. Command send. Flight payload confirm receipt of command. Copy payload.
And...
Stand by for shepherding spacecraft impact.
Very last seconds of the shepherding spacecraft trajectory as it approaches the lunar surface. We are seeing very small craters.
Wow.
in the crater.
we confirm a thermal signature of the crater. Our mid-IR cameras,
That's it.
over.
Copy science. We just received flight shepherding spacecraft impact. Stations report LOS.
The ground stations at Goldstone just reported
Last trackage 11:35.054 seconds.
the shepherding spacecraft has hit the surface of the moon, and this marks the end of the LCROSS flight mission.
Okay, all stations flight. Great job. First step 179. Complete closeout of your flight products and get them on NDPS.
How long will it take them to release the actual photos
Oh, that's why
of the plumes?
that's not gonna happen.
Okay.
There is no plume.
It was supposed to be.
Yeah.
Well, Michael, I wonder if you could give us your impressions
I would have seen small
of what we just
craters
saw and mission
if there had been
success.
plume.
Well, it's hard to tell what we saw there. I'm not sure. Not sure if the gain was set there correctly or what. We had some confirmation from the mock that they did have a thermal signature. I should mention that the 9 instruments on the trailing spacecraft, the LCROSS spacecraft, were exercised on the way to the moon. In fact, we took images on the way and images of the Earth, so we're confident the instruments performed as expected. At the time of the impacts, the mothership, the Lunar Reconnaissance Orbiter, or sister ship, I should say, was about 50 kilometers overhead. They will have their first, and so they should have been seeing this with their suite of instruments. They do their first data downlink in about 2 hours or so. So we hope to have the data, and I expect we will be receiving both imaging data and spectroscopic data from the host of ground-based observatories probably within the next few hours. I think it is fair to say that within this $79 million cost cap, as I mentioned earlier, the experiment had been optimized to produce the largest possible impact plume. And so I remain confident that this is our best opportunity to date to measure the extent of water ice on the moon.
So what we're seeing here is a replay of that impact. Let's
9 instruments on the trailing LCROSS spacecraft, which you see going in here, they basically break into 3 categories. There was something called a flash radiometer, which should have seen the flash, and by virtue of analyzing that signal, we can make some inferences about the depth of the regolith, and it's the makeup of the dirt, as it were, that was thrown up by the Centaur impact.
Right, so brighter flash means, hit rock, and dimmer means it hit dirt, essentially.
Right, and actually you would want a dim flash here, because that is suggestive that you hit sandy material.